this video is going to be about conditional and biconditional statements. So here's an example with a conditional statement. We start out with two statements. Statement P, today is a holiday. Statement Q, the store is closed. Now, I can put these two statements together into one statement, a conditional statement, sometimes called an if and then statement, and that's going to be, if today is a holiday, then store is closed. Or I could just say P, then Q, and I can write this with symbols. I can put P and an arrow and an Q. With the arrow from P going to Q. And this is read as if P, then Q. Sometimes it's read as P implies Q. Now, let's find out what is the truth value for a conditional statement looks like. So, to do this, I'm going to need a column for the truth values of P. Another column for Q, and the third column for if P, then Q. Let's put in the possible values for P and Q. So, P and Q might be both true. Or P is true, then Q is false. Or it can be P is false, then Q is true. Or it can be both false. So what we're doing is, we're thinking in terms of the conditional statement. If today is a holiday, then the store is closed. And we want to see whether the expectation we would have from different conditions are met. So here's what I'm getting at. I know that today is a holiday and the store is closed. Then my expectation has been met. I expected the store will be closed because it was a holiday. So this is a true statement. If today is a holiday and the store is not closed because Q is false, then my expectation has been not met. I expected that since today was a holiday, the store will be closed. But the store is not closed, so this is a false statement. I'm going to jump down to the condition where they're both false. Today is not a holiday, and the store is not closed. Well, I didn't have any reason to expect the store to be closed because today is not a holiday. So, that's also going to be true statement. The condition that gives people difficulty sometimes, if P is false and Q is true. In other words, today it's not a holiday, but it's true that the store is closed. Now, you might have expected that if it wasn't a holiday, the store would be open. But the statement we started with is, if today is a holiday, the store is closed. We didn't say that was the only reason the store might be closed. There might be other reasons. So, in other words, we have no reason to know just because today is not a holiday that the store is definitely going to be open. The store could be closed, so this is considered to be a true statement. When P is false and Q is true, you've still got if P, then Q being true. We also have something called biconditional statement. Biconditional statements work like this. We got statement P, 5 plus 5 equals 10, and statement Q, 2 times 5 equals 10. Now, if you think about it, I could given these two statements, I could say if 5 plus 5 equals 10, then 2 times 5 equals 10. And that in fact will be true. I could also state them in the other order. If 2 times 5 equals 10, then 5 plus 5 equals 10. Now, if I can take both of these statements, reverse them, and get some result in a conditional statement, then this is what we call biconditional. We can say this as 5 plus 5 equals 10 if and only if 2 times 5 equals 10. Or I could say it in the other order, 2 times 5 equals 10 if and only if 5 plus 5 equals 10. If I want to write this symbolically, I'm going to have a P and a two-headed arrow and then the Q. So the arrow points in both directions, both to the P and the Q, meaning that I'm taking two regular conditional statements, putting them together. One in one order and the other in the other order. And so, I'm combining them into a biconditional statement. And again, when this is read, usually we'll say something like P if and only if Q. Here's what the truth table for this looks like. So, we'll have that value for P, the value for Q, and the values for P if and only if Q. So again, P and Q might be true, or P might be true and Q might be false, or P might be false and Q might be true, or they both false. Now, if it is true that P 5 plus 5 equals 10, and the statement Q is true that 2 times 5 is equals 10, we're going to have a true statement. If I know that 5 plus 5 is equal to 10, I can expect that 2 times 5 is equal to 10. And similarly, if I know that 2 times 5 is equal to 10, I can expect that 5 plus 5 is equal to 10. And now, when one statement is true and the other statement is false, like when I know that 5 plus 5 equals to 10, but it turns out that 2 times 5 does not equal to 10. Well, that's not going to be meet my expectation, so that is false. In the same way, if I found out that 5 plus 5 does not equal to 10, but 2 times 5 does equal 10, then I'm going to have a false. So, if either one of your P or the Q is false, you're going to have a false. If they are both false, however, it's going to be true if 5 plus 5 didn't equal 10. I'd have no reason to expect that 2 times 5 would equal 10. Thinking it in the other direction, if 2 times 5 didn't equal 10, I'd have no reason to believe that 5 plus 5 would equal 10. So, when they're both false, my biconditional P, if, and only if Q is going to be true. So, that's all for today. Thank you!